In this video, we'll look at sketching a graph for the Limacon. If you are French and I am butchering that pronunciation, please forgive me. There's going to be two different kinds. One will not have an inner loop, and it's not going to touch the pole like the cardioid does. Notice this looks very similar to a cardioid, but remember the cardioid actually touches the pole. Here it does not. We could also have a Limacon with an inner loop that does touch and pass through the pole. So the different equations for those: first, without a loop, we have r equals a plus b cosine theta, or we could have sine theta. R equals a minus b cosine theta, or also with sine theta instead of cosine. Here, a is always positive, b is always positive, and in this case, a is greater than b. That's what creates the version that does not have a loop. Notice that these formulas down here are the same, but the difference is a is less than b. So a and b are still positive, but this time a is less than b. This will generate a graph that does have the inner loop and passes through the pole. It actually passes through it twice. Once, loops around, twice. Again, when we're sketching these graphs, we're going to rely heavily on technology to do this. Some of you may be in other classes that require a lot more work by hand and point plotting. For us, we will focus on technology. We may make some notice of symmetries, but again, for the most part, it will be technology based. So here we're looking at r equals 3 minus 2.5 sine theta. In the calculator, first of all, make sure your mode is set to radians and polar. From there, we can go to y equals, and notice r equals is there. We'll type in the equation, 3 minus 2.5 sine theta. And from here, I'm going to hit zoom 6 to standardize the window to give us a starting place. And we want to zoom in a little bit. I'm going to just make notice of what my maxes and mins are, and then we can go to the window to make some changes. Let's make the theta min negative 2 pi. Theta max is already 2 pi, that's good. Theta step looks good. The x min, let's change that to, I think it was negative 4 would be a good one. X max is positive 4. The x scale we'll leave at 1. Y min, if I remember correctly, negative 6 would work. And y max, let's push that down to 2. Y scale we'll leave at 1. So let's graph and see what we got. And it looks pretty good, but again, it's rectangular because of the default Windows setting. If we wanted to change that to make it a little more square, we could hit zoom 5. It's going to change our settings, but it'll make it look a little prettier on a square grid. Notice again that this kind of looks like a cardioid, but remember, cardioids actually touch the pole. So don't confuse these. Be careful. To get some points to plot, we can, again, if you haven't seen this already, we can go to second zoom, which will take us to format. We need to make sure that polar GC is on. And from there, we can hit second trace and value. We can pick some values for theta that is going to help us get some coordinates to plot. Let's start at 0. On the polar axis. It looks like it's at 1, 2, 3. Let's confirm that. And indeed, we get r equals 3. So on the polar axis, 1, 2, we have a value of 3. Let's see what's happening at pi halves. It looks like r is going to be 1/2. Let's confirm that. Again, second trace value. Let's make that theta pi halves. Let's see what's happening on the y-axis. And r is 1/2 as it looks like. So let's put a point at 1/2. It looks like we have some symmetry, so it looks like we're symmetric about the angle pi halves. That means the other r will be 3 as well. So 1, 2, we have a 3 over there. We could confirm that by hitting the value and seeing what's happening at angle pi. Let's see what's happening at 3 pi halves. It looks like it's 1, 2, 3, 4, 5.5. Let's confirm that. Second trace, number 1. And let's see what's happening at 3 times pi divided by 2. And we do get 5.5. R is 5.5, which is 1, 2, 3, 4, 5. A little off the grid down here. If we wanted a more accurate sketch, we could continue to get some more points using different values for theta to get more points to plot. But for now, let's just quickly sketch what we. It's certainly not perfect, but we have a sketch, at least, of this graph. In the next example, we want to do 3 plus 4 cosine theta. And we'll probably have to change the settings, but let's see where it is right now. Looks like we need to make the x and y maxes a little bit bigger. So let's go to our window. Let's make the x max maybe around 8. And the y max, let's make that 5. Make sure we can see the entire graph. We can. And now again, let's do zoom 5. So square it. And we have the Limacon with an inner loop this time. Notice we have an inner loop because B is bigger than A, whereas over here, B was smaller than A. To get some points to plot, we can again go to second trace and hit number 1 for value. At 0, let's see what we get. We get 7. 1, 2, 3, 4, 5, 6, 7. So I'm a little off the grid here. Let's see what's happening at pi halves. It looks like it's at 1, 2.5, maybe 3. Let's see. Second trace, number 1. And let's see what's happening at, again, pi divided by 2. We get 3. So 1, 2, 3. It looks like we have symmetry about the polar axis. That means we're going to have -3 on the y-axis as well. And it looks like we're going through the pole. So I'm going to start at the pole, create my inner loop, go through the point down here. It's going to wrap around to that 7, and come back to that point and go back to the pole. So it's certainly not perfect, but we're just going for a quick sketch. Once again, if we wanted to be more accurate, we could get a lot more points by simply using second trace and looking at different values for theta to get those additional points.